Welcome to this demo of Nakisa Decision Intelligence platform. Today, we'll see how you can automatically validate your workforce data against your organizational design principles, like workforce composition, compensation trends, and structural rules. But first, let's discuss what Nakisa Decision Intelligence is. NDI is an enterprise-grade AI platform that transforms complex data into strategic insights and guided actions via natural language prompts. NDI leverages multiple AI agents to connect fragmented data and transform complex business questions into instant, actionable intelligence. This continuous flow of insight empowers leaders to drive org transformation, proactively anticipate change, and maximize impact across critical initiatives like mergers and acquisitions, rapid scaling, and complex business pivots. Now let's move straight to the demo. We'll begin in a new chat using our HR dataset. For this video, we'll be conducting an in-depth analysis of our workforce analytics against best practices we've defined. For any organization's guardrails or rules, NDI supports uploading documents. In this demo, we've uploaded a file containing our organization design principles. We can start by asking NDI to review these principles. The system has learned our principles and presents them in an easy-to-read format. If needed, we can click on the suggested replies for deeper explanations on the given answer. We can drill down into a specific rule to get insights and recommendations. Let's first run a validation of our fourth rule, which focuses on workforce distribution, including target proportions for managers, executives, and critical roles. NDI analyzes our internal data and confirms whether our workforce distribution aligns with our principle. It appears that our managers, executives, and critical roles are all within the target range. Though our overall averages show no deviation, we can take a deeper look by drilling down into percentages of critical roles by department to ensure the metric is consistent across the board. The system creates a bar chart showing the detailed percentage of critical roles per department. Some departments, such as cloud computing and legal, are skewing our average upward, while many others have a lower percentage, which suggests that action may be needed, such as reclassification or planning for future skill requirements. Great, we've instantly validated an important composition principle, gaining insights per department. Now, let's dive into workforce costs by running a validation check for rule number 5, which specifies that each position's pay grade should be lower than its parents. The system begins by listing every position that violates this principle, including the position ID, name, pay grade, and the same information for the parent position in a table. We can easily put the table in full screen for a complete view, or download it as an Excel file. Having surfaced all the non-compliant positions, we can now review all the exceptions and proactively correct them to stay aligned with our internal rules. Our next principle, based on workforce costs, is the gender pay gap. To prepare for DEI and compliance reporting, we can quickly run a validation check on this specific organizational design principle to flag areas where the gender pay gap is too large. NDI lists and flags the job families with an excessive pay gap in a detailed table. Let's take one of the departments listed, like the product management department, and ask NDI to drill down on the gap per pay grade to understand what might explain the imbalance. The results show that across multiple pay grades, the gap far exceeds our acceptable limit. Let's focus on grade 01 and go deeper by asking NDI to incorporate more factors into the analysis, such as skills, tenure, performance, and potential. For this demo, we'll focus on our executives' compensation to address any anomalies. The system generates a detailed chart for executive-level employees, helping us compare compensation and determine whether it aligns with any of the factors we just listed. To facilitate the analysis, let's ask NDI to assist and uncover the reasons behind any compensation disparities. For example, we can follow up and ask if tenure is a significant factor. NDI provides a detailed analysis, comparing different factors and highlighting possible underlying causes. While there are several potential explanations for the pay gap, it appears that tenure alone is not sufficient. The most likely cause surfaced here is due to other factors, like external hires coming with higher entry salaries and negotiation variance when starting the job. This may warrant a review of hiring practices and salary band governance. This inequity in compensation could lead to a risk of losing talent. NDI also supports more complex what-if simulations. Let's prompt NDI a bit further by asking for a turnover risk estimate due to this pay gap. Using external benchmarks and industry averages, the system gives detailed estimates for talent loss and voluntary turnover if no corrective action is taken. It appears that correcting this issue should be a high priority. Let's ask NDI to model 3 scenario options: one that brings the organization into compliance, one that aligns compensation with the market, and one that supports long-term equity correction. We receive 3 detailed scenarios, each with a list of pros and cons, along with an estimated cost based on market compensation and our current data. Of course, long-term equity would have the greatest impact on morale and serve as the most future-proof option, though it also comes with the highest cost. Through a few simple questions, we've gained deep insights into the reasons that could cause the gender pay gap in this department, the risk it poses, and different action plans to tackle it. For executive presentations, we can export the table and the graph to quickly show the insights gained through these NDI prompts. Finally, the last design principle we'd like to validate for this demo concerns structural health. Let's start by displaying a chart of the average span of control per department compared to our target ranges. We then get a clear chart showing each department's average span of control, along with the target lower and upper bounds we've set for them. Again, we can open the graph in full screen and download it. To focus on a specific department, we simply prompt NDI. For example, we can generate a list of managers in finance to drill down into their span of control and suggest targeted organizational design improvements. NDI provides the full list of specific positions, including each incumbent, their span of control, and target values. By skimming through the table, we can click on the incumbents' profiles, which takes us directly to the Nakisa org chart software. Let's choose our VP of Finance with the highest span of control. We access her profile in Nakisa org chart. From there, we can analyze the position details more in depth or click to visualize her team on the org chart. From there, by simply clicking on Edit, we move to Nakisa org design. By creating a new proposal, we can suggest tactical changes to reduce the span of control based on structural issues detected earlier with NDI. Thank you for joining us for this demo of Nakisa Decision Intelligence. We've just seen the power of NDI firsthand. With simple, natural language prompts and the benefit of expert-level recommendations, you can instantly validate multiple organizational design principles across key dimensions, including your workforce composition, costs, and structure. The best part? You don't need technical expertise to create charts, run complex what-if scenarios, or perform deep analysis. Nakisa empowers you to make informed decisions and take immediate action, all while benefiting from the speed and efficiency of being seamlessly integrated with your existing Nakisa solutions. For more videos on the Nakisa Decision Intelligence platform, subscribe to Nakisa's YouTube channel, where we'll be featuring more practical examples, tips, and best practices to help you unlock business value.